Here we have two matrices. A, first row -1, 0, 1, second row 0, 1, 1, third row 2, 0, -1. And B, first row 1, 0, 1, second row -2, 1, -1, third row 2, 0, 1. Let's multiply them. Let's find the product A times B. Let's call the result matrix C. Let's observe that since A is 3 by 3 and B is also 3 by 3, the result C is also a 3 by 3 matrix. Okay, so then in entry-wise notation, C has first row C11, C12, C13, second row C21, C22, C23, third row C31, C32, C33. Okay. To obtain the entries C11, C12 all the way to C33, we take dot products of rows of A and columns of B. So let's look for C11. C11 is the dot product of the first row of A and the first column of B. So that goes as follows. -1 times 1 plus 0 times -2 plus 1 times 2. So what do we get from that? -1 plus 0 plus 2. The result is 1. Let's find C12. C12 is the dot product of the first row of A and the second column of B. What is that? -1 times 0 is 0, plus 0 times 1 is 0, plus 1 times 0 is 0. Result is 0. C13, dot product of the first row of A and the third column of B. What is that? -1 plus 0 plus 1. The result is 0. Okay, next row of C. So let's begin with C21. C21 is obtained by taking the dot product of the second row of A and the first column of B. So what is that? 0 minus 2 plus 2. The result is 0. C22, dot product, second row of A, second column of B. 0 plus 1 plus 0, which is 1. Now C23, second row of A, third column of B. What is it? 0 minus 1 plus 1. The result is 0. Finally, the third row of C. C31, dot product, third row of A, first column of B. What is it? 2 plus 0 minus 2, which is 0. Okay, C32, dot product of third row of A, second column of B. The result will be 0. And finally C33, dot product, third row of A, third column of B. After you do the calculation, the result will be 1. Okay, so here is our summary. We just multiplied matrix A times matrix B, and we found it to be the identity. Conclusion, B is the inverse of A. That's my matrix A. This other matrix gets its inverse because upon multiplying A times that matrix, we got the identity. Okay, so here is a question. Suppose I am given matrix A. Suppose I know that there is an inverse of that matrix. Suppose there is, so I'm given A, suppose there is some matrix B that when you multiply it to A, gives you the identity. Now, if you know that, but you don't know B, how to find it? How to find the inverse of A? So that's our next task. Okay, so here's the question. I'm given this matrix A, and I want to find its inverse. Here is a procedure that will do the job. We're going to create an augmented matrix with two blocks. The left block will be the matrix A. The right block will be the identity matrix of same dimensions as A. So let me copy A. Here I will have A. -1, 0, 1, 0, 1, 1, 2, 0, -1. Here I will have the 3 by 3 identity matrix. 1, 0, 0, 0, 1, 0, 0, 0, 1. Okay, so here's the procedure that we need to go through. We need to reduce this matrix into reduced row echelon form via elementary row operations. Now, we start as follows. Go to your first row. The first non-zero entry should be in the first row, first column of that matrix. Make it a 1. Right now, that requires I multiply the first row by -1. So apply that elementary row operation. -1 times the first row of the augmented matrix. Okay, so here's what you obtain. That's going to be 1, 0, -1, -1, 0, 0. Everything else remains unchanged. So 0, 1, 1, 0, 1, 0, 2, 0, -1, 0, 0, 1. Okay, next, you will go to that first non-zero entry in the first row. That's going to be our pivot. That's called a pivot. We're going to utilize that non-zero entry to eliminate every other non-zero entry in that column. So in this case, all I have to do is eliminate that too. How? Take row 3 minus 2 row 1. So row 3 minus 2 row 1. Okay, so 2 minus 2 is 0. Mission accomplished. You wanted to make that a 0? Mission accomplished. 0 minus 2 times 0 is still 0. -1 minus 2 times -1 is -1 plus 2. -1 plus 2 is 1. 0 minus 2 times -1 is 0 plus 2, which is 2. 0 minus 2 times 0 is 0. 1 minus 2 times 0 is 1. Everything else remains unchanged. So that's 0, 1, 1, 0, 1, 0. 1, 0, negative 1, negative 1, 0, 0. Okay, next, once you've done using the first pivot to eliminate every other non-zero entry in that column, you go to the next row. The first non-zero entry of that row, you will make it a 1. In this case, it is already a 1. Next, you will utilize that new pivot to eliminate every other non-zero entry in the column of that pivot. In this case, that's already done. There is a 0 there and there is a 0 there. So they're already eliminated. So then move on to the next row. The first non-zero entry of that next row, make it a 1. It is already a 1. So use that new pivot to eliminate every other non-zero entry in that column. So you want to eliminate those two non-zero entries by using that non-zero entry. Okay, let's get rid of the negative 1 first. How? Take row 1 plus row 3 to replace row 1. So here we're going to take row 1 plus row 3 to replace row 1. So 1 plus 0 is 1. 0 plus 0 is 0. Negative 1 plus 1 is 0. Mission accomplished. That's what we wanted. Negative 1 plus 2 is 1. 0 plus 0 is 0. 0 plus 1 is 1. Everything else remains unchanged. So 0, 1, 1, 0, 1, 0, 0, 0, 1, 2, 0, 1. Okay, now we have to eliminate the other non-zero entry that remains to be eliminated, which is the 1. So in this case, I'm going to have to take row 2 minus row 3 to replace row 2. So row 2 minus row 3 to replace row 2. Okay, so 0 minus 0 is 0. 1 minus 0 is 1. 1 minus 1 is 0. Mission accomplished. That's what we wanted. 0 minus 2 is negative 2. 1 minus 0 is 1. 0 minus 1 is negative 1. Everything else remains unchanged. So that's 0, 0, 1, 2, 0, 1, 1, 0, 0, 1, 0, 1. Okay, so we are done. We started with the augmented matrix consisting of two blocks, A in the identity with same dimensions as A. We applied elementary row operations until we arrived at a reduced row echelon form matrix. So what's the significance of what we obtained? First, we confirmed that A is row equivalent to the identity. So we just confirmed that A, in fact, is invertible. But we also obtained something else. We obtained this block right here. That happens to be the inverse of A. That's the method that we are using to find the inverse of A. We begin with the augmented matrix consisting of A on the left block in the identity on the right block, we apply a sequence of elementary row operations up until we obtain the reduced row echelon form matrix that has the identity on the left block and has the inverse of A on the right block. Okay, confirmation. Did we actually get the correct answer? Of course, the answer is affirmative. That was the inverse of A. Okay, we're going to try another example, a bit simpler. Here we have a 2 by 2 matrix. A equals to 3, -1 first row, -4, 2 second row. Let's find the inverse of A. Our hypothesis is that A is invertible. Our procedure: we form the augmented matrix where the left block is A and the right block is the 2 by 2 identity matrix. We then apply a sequence of elementary row operations to obtain a reduced row echelon form matrix, which will have left block the identity matrix, right block the inverse of A. So let's begin. Let's form our augmented matrix with a left block A, right block the 2 by 2 identity matrix. Three, -1, -4, 2, and then 1, 0, 0, 1. Okay, so first, we look at the first row. The first non-zero entry, we want it to be 1 to become our pivot. So we need to multiply the first row by 1/3 to make that happen. So multiply row 1 by 1/3. So here is our result. 1/3 times 3 is 1. 1/3 times -1 is -1/3. 1/3 times 1 is 1/3. 1/3 times 0 is 0. Everything else remains unchanged. Next, we now want to use our pivot to eliminate every other non-zero entry in the column of that pivot. So that means we want to get rid of this -4. To accomplish that, we're going to take row 2 plus 4 times row 1. And that will replace the second row. Okay, so let's begin. -4 plus 4 is 0. Mission accomplished. 2 plus 4 times -1/3. 2 plus 4 times negative 1/3. That is the same as 2 minus 4/3. So now we are subtracting fractions. Let's make 2 a fraction, which is the same as 2 over 1. Denominators need to be the same, so we multiply the numerator and the denominator of our first fraction by 3. So we end up with 6 over 3 minus 4 over 3, which is 2/3. 2/3. Zero plus 4 times 1/3 is 4/3. 1 plus 4 times 0 is 1. Everything else remains unchanged. So we have 1, negative 1/3, 1/3, 0. Okay, now we're going to go to the next row. So in this case, the second row. We want to make the first non-zero entry of that row a 1. So that means we need to multiply our second row by 3 over 2, the reciprocal of 2/3. So multiply row 2 by 3/2. Zero times 3/2 is 0. 2/3 times 3/2 is 1. That's what we wanted. Careful with the arithmetic here. 4/3 times 3/2. The 3's cancel, and then 4 over 2 becomes 2. And finally, 1 times 3/2 is 3/2. Everything else remains unchanged. We have this. Okay, now I'm going to use my new pivot to eliminate every other non-zero entry in that column. In this case, get rid of the negative 1/3, make it a 0. To accomplish that, we're going to take row 1 plus 1/3 row 2. Row 1 plus 1/3 row 2. Okay. So that replaces the first row. So 1 plus 1/3 times 0 is still 1. Negative 1/3 plus 1/3 becomes 0. Mission accomplished. That's what we wanted. Now we have 1/3 plus 1/3 times 2, which is 2/3. 1/3 plus 2/3 is 1. Now I want 0 plus 1/3. 0 plus 1/3 times 3/2. Notice the 3's cancel, and we end up with 1/2. Everything else remains unchanged. So our second row remains 0, 1, 2, and 3 over 2. Okay, so we have obtained our desired reduced row echelon form matrix. What do we get from this? First, we get confirmation that our original matrix A is row equivalent to I. In other words, it is invertible. And we also get what we were looking for, the inverse of A. To confirm that there were no errors, I had worked this previously, and our answer is correct. Okay, that's all for this video.